Well, welcome everybody. We're glad to be back with you. We had a couple of months off here because of the holidays, and first one thing and then another. And we're glad to be back with everybody with our broadcast engineering webinar that we produce each month. It's usually on the third Tuesday of the month, and we look forward to having you folks with us from time to time as we go through the year. This program is actually underwritten by Max Connect Group. If you haven't looked into this little device, it's out now. Just go to www.maxconnect.com. It allows you to use IP for all different types of transmission to the transmitter or from studio to studio. So we appreciate their sponsorship on the program today. We wanted to talk today about audio, and more in particular about loudness. Now loudness, I hope, and I'm sure that our guest today will talk about that quite a bit. But the loudness war, I hope, is already diminished and gone away. I know that it was really a big thing several years ago, but it looks like it sort of died out today. But what we do find now is if you listen to a radio station, and I don't know how many of you have noticed this, but there seems to be from time to time a difference in loudness between the different elements in a particular radio station. Maybe from a commercial to a song or a newscast or whatever it happens to be. And so this seems to be a problem. So I invited our good friend, Frank Foti, who's been with us before. And Frank, we're glad to have you with us today.
Thank you. Thank you for the invitation. And Larry, can you speak a little louder? No, just joking.
Oh, okay.
No, I'm joking. Loudness, get it? You know.
Oh, I see. A little pun intended. No pun
Larry,
intended.
it's sick, left-handed Sicilian humor.
Oh, is Silvio there with you this morning?
Oh, he's with me constantly.
Okay. Well, Frank, what we wanted to talk about, and I'd like to have your thoughts about it. And before we actually start beginning to talk about that, let me offer a little theory that I've had all my life, and maybe I might be in the minority of this, but I've never quite understood why there's so much push to be loud. Especially, I know you got two different types. You got the mixing folks that produce records, and they always want to have the loudest cut, on the air or on the stream. But radio stations for years wanted to be really loud, and I may be in the minority on this, but I don't really believe in my own mind that people tune up and down the dial and they stop on the loudest station. They stop on the station that has the format and the content that they want to listen to. And years ago, when radio first started, somebody had the brilliant idea to put this little knob on the left-hand side that said volume, and you can adjust it to however you want it. I would like to have your thoughts on that, Frank, and why there's been so much push to be louder than the station down the street.
Well, Larry, on the surface, your perspective is one that I'm in agreement with. And there's probably a lot of folks here who have gathered with us saying, Frank, why would you say that? You make a box that is designed to deal with audio levels and perceived loudness. To the point, though, I think what it is it's a subliminal psychological approach that generally, not that broadcast engineering, decided upon, but more so the management / programming folks decided upon. And where it hails from, actually, believe it or not, it hails from the good old days of big, powerful AM radio stations. And when you think about it, in AM, when the more we could generate, RMS level in modulation, you basically were helping to fill in those, weak gaps in your coverage. And, that was also the other appeal, if you will, running asymmetrical modulation. The FCC allows us up to 125% positive modulation on AM. And you had, programming folks that wanted to maximize coverage. So in their mind, it's like, man, you got to, crank it up, man. And what ended up happening is that as contemporary radio or top 40, up-tempo formats migrated in the late 70s, early 80s onto FM, a lot of those program directors, and I'm being fair to them here, they were of the same thinking. Well, on AM, we had to crank the signal to get coverage. Well, on FM, we got to crank the signal to get coverage, not ever realizing that on FM, if you had the processing really, really quiet or blastingly loud, the coverage was basically going to be the same. Now, there's another psychological thing there, and that is bigger is better, right? Now, that's, some people may not agree with that, but it's that subliminal thought that as you're scanning the dial, if something jumps out of the speakers, somebody, and I agree with you about the programming, that's how I listen. But if there's something subliminal to where as you're scanning the dial, back in the days when we had the old, the non-digital radio dials, if something grabbed you, you might go, what's that? Or if it appeared louder, then people might think, well, their signal's bigger. There's, the station is bigger. And, before the webinar started, I was, and I'm not trying to put another plug in here for the movie, but, when we launched Z100 back in '83, and Scott Shannon, by the way, talks about this in the movie, he said, look, I got to have something that appears to be like a flamethrower. Granted, all the signals were coming from the Empire State Building or World Trade. We had the same coverage. But if you scan that dial, when you hit 100.3, I mean, it grabbed you. Granted, and the appeal there is that it's a subliminal enhancement to the programming. And in the case of, that particular radio station, that and I've had people tell me to this day, Frank, while the programming was top, no matter what, there was that subliminal grab that you knew when you hit Z100. The last thing I'll say, Larry, is that it wasn't designed to just be loud. It was punchy loud. It had a feel of like there was still some detail, the appearance of dynamic range, but it had this thing where it would the best way, Roger Daltrey used to always, he used to always describe the music of the Who. And that was like, I'm punching you in the nose and saying, I love you. And that was the appeal.
But there's a difference, and it has to sort of go along together. I think there's a difference in quality and quantity.
Of course.
But if you can marry the two up together, then that's what makes a outstanding station.
When, to your point, and people have asked me this, back in that day, electrically, the competition, WPLJ, was probably electrically louder than Z100. But the perception was that Z100 was louder because of the way the audio processing was set up. And so one of the things, and I know we're going to talk about some of the technicalities regarding loudness, but something that I want to point out, and I've said this for decades now, I think the whole term loudness has gotten a bad name because it's been abused, either in broadcasting or in the mastering of CDs, where people overly pushed the limits. They didn't know what they were doing, or they didn't, set the gear, be it processing or their application, in a manner to create a loud yet appealing signal. That can be done if you're mastering a CD, an audio file, as well as you're putting something on the radio or television. And looking at some of your points you wanted to discuss today, and you'd mentioned earlier about why is the newscast one way and the commercial too loud and then the content is too soft. Well, that all comes back to how things are being operated, and if things are set up properly, theoretically, there shouldn't be any issues.
Yeah, I was at a station one time and the engineer made mention to me. He said, look at my modulation monitor. And I looked at it and it was broke. I thought it was stuck on 85%.
Yeah.
And
It looked like a current monitor.
Yeah, he said, isn't that great? I said, yeah, well, yeah, I guess, unless you don't want people to listen any more than 15 seconds, because it had no dynamic range. And I think that's what you were talking about, is you gotta have both.
Yes, without question. So I have sat in on a number of these AES committee meetings on loudness, and now the AES has a standard thing. I think, quite honestly, I think a lot of it's a Band-Aid, because by example, in Europe they have this MPX power limitation, to where the calculated power of the MPX signal cannot exceed a certain level. And all these broadcasters adhere to it, but what a lot of them do is they still crank up the signal, yet scale the modulation back to get the affected sound that they're looking for. It really does come down to how things are applied, because I've heard some of the stuff that's using loudness monitoring or loudness control, and if it's not set up correctly, it doesn't sound correct, doesn't sound natural. And at the end of the day, you want it appealing, you want it to sound natural or musical if it's music is the content. But again, it comes all the way back to something that Larry, you and a lot of the folks whose names I see here on the screen have dealt with for many years. If you're not managing the application or the equipment properly, the results will be less than desired.
I think it was actually one of the things that's probably made it even a bigger problem was the transition from analog to digital, because in analog you did have, especially in the recording end of it, you did have a limitation. They were just so loud you could make something. You couldn't, on a vinyl record, if you made it any louder, the needle would jump off the record, off
Right.
the groove. But
Right.
then when we moved over to digital, then a lot of the restrictions went away as far as that's concerned, and people sort of took advantage of that and said we can just push the limit. But there are some limits, and I think that's where the problem is. I think Bob Katz, I think, and Bob had mentioned one time that one reason that digital doesn't really sound as good as it can be or should be is that the engineer has not taken the time to look under the hood to see exactly how digital works, bit depth, sample rate, dither, and stuff that way. And you really have to understand that, and it's not difficult to understand, but you really got to understand that if you're going to do it correctly and create a product that will be pleasing to the audience.
Well, yes, but there's something about digital that I think some folks become confused over with respect to analog. In the analog world, if you run out of headroom, as you're running out of headroom, it's a bit more forgiving. Think about the whole aspect where people would do soft clipping using tube circuits, right? In digital, there's no forgiveness. Full scale is full. There is no 2 dB full scale, and this is why I'm emphatic on this, because the issue in the digital world is if you try to go beyond full scale, it's going to distort, but you have an added distortion component that you don't have in the analog world, and that's called aliasing distortion. And some of the early digital based processors that were released in the early 90s, they all suffered from aliasing distortion. Their designers will, act like politicians and claim, no, they didn't. But I did the research. And one of the reasons why our products have done as well as they have done is because I had a buddy, Steve Church, who was the first to apply DSP in broadcast, who said, Frank, there's something called aliasing distortion. And if you don't pay attention to it, once you create it, you can't get rid of it. And that's something. Why am I saying this? Because the whole hypercompression issue that came about, just around the turn of the century, where all those CDs were just like smashed. What those guys didn't realize was that they were clipping in the mastering device, but they were generating clipping at a very low sampling rate of 44.1 kilohertz, causing all sorts of aliasing distortion that's embedded in the final product, and you can't get rid of that. So, the analogy is understand where the maximum point of your headroom is in the digital domain, just as we did in analog. How many of us would reference everything to the, basically the power supply rails in the console, either plus 22 or plus 24, and then we just left about 20 dB of headroom, and everything pretty much behaved. So if you think about it, if you look at a lot of operating meters like VU meters in the digital world, if things, what usually ends up happening is they'll reference 0 to being about 20, 22 dB below full scale. And then if you're able to do that and operate within that domain, you shouldn't have any issues.
Well, in the olden days, I think a lot of people, they wanted to run the audio as loud as they could in recording to get above the noise floor, because
Sure,
there was a bad situation with noise floor back then. But in digital, the noise floor is so far down, that's not a problem anymore.
That's right.
But yet people still try to run up to 0 dBFS, and that 0, as I heard somebody say one time, when you hit 0 dBFS, the digital word is all ones.
That's right.
And you've run out of ones, and you can't run down to Radio Shack and buy another bag of ones. They're gone.
Right.
And so the encoder just really goes to pot at that point. So you don't really need, and most of the mix engineers that you and I work with, our good friend Andrew Shepp and Chris Lloyd Alge and all that, normally stay down to like -1. That's their cliplet. When they put a limiter on it, that's where they try to do it, so to give you some room. Now, one reason they do that, and you might comment on this, and this is something I just not too long ago finally understood. There's something called intersample problems in that happens in the D to A converter, that even though you may be hitting 0, when the D to A converter tries to convert it back to analog, that creates a problem.
Well, yes, there is something, and a lot of it comes down to based on the sampling rate and what we call either sample slipping or the intersample scenario as you described, and not knowing, because a lot of times an whatever A to D method has been used may not be its method of doing conversion into the digital domain. Well, the reciprocal back to analog may not be the same process, meaning how it's being done. And if you're sitting too close to full scale in that process, you can generate overshoots, which they're going to cause clipping. They're going to cause distortion. So again, one of the things I've always looked at is to try to keep the peaks, not the operating level, the peaks, 1 to 3 dB below full scale. And if you do that, you're generally going to be okay.
Now, I've heard a lot of engineers talk about, there is a rule of thumb. It's not set in stone, but in practice, I guess, is they not try to go over -12. That that gives you a really good headroom.
Yep.
The other thing that I wanted to talk about, we've talked about in the recording mechanism, but one of the other problems that we seem to have, and this is what you and I talked about when we were discussing about this program, was how the human auditory system works. it's really a situation where uh, everybody's hearing is different. What sounds loud to one person is going to might be too soft for somebody else, or just right, or what sounds too low might be too loud for somebody else. And we have to, I think, and I know you folks do a lot of that research when you're designing your processor and all, but you got to take into account how the human ear and the human brain works and make it come out pleasing to everybody, or as well as you can.
Well, that okay. The simple answer is yes, and by example, within my own team at Omnia, like my ear is very sensitive to what I call intermod distortion. And I've got a couple of my colleagues who have great ears, know how to set processing. Their ears are less sensitive to intermod, excuse me, but their ears are more sensitive to harmonic distortion. So many times when we're working on like algorithm design, we'll kind of pass it around among ourselves so that, we'll play, okay, kind of meets my Kool-Aid acid test, and, have someone else see if it passes their Kool-Aid acid test. And then over time, if we get somewhat of consensus, then we know we're onto something. And I'm saying that because we all, just about every one of us, hear things just a little bit differently. And when you think about how, since probably dealing with a lot of folks here today that, are involved in radio, that's one of the reasons why I've always recommended for those that are setting audio processing, you don't want to set it with a committee because you'll never get consensus. You need to have a single person who's going to be the final say so, good, bad, or indifferent, and it's going to get set to that direction and then hopefully left alone. Because every time I've been around where there's been, somebody wants to have a committee, it's never worked. And by the, my own experience, either in working in radio or designing this stuff, or even as a consultant, I can't tell you how many times I've, been around and, somebody inevitably will come around and go, you know what? I know you want those snare drums to sound nice and sharp, but blah, 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 blah. And in my mind, I keep thinking, you know what? If it's your radio station or you're the person with the final say so, then you get to have the final say. But, at the end of the day, I think the successful operators are those that have an idea, they have a goal, and they set it, and they get it to where they want it to be. And hopefully if it's appealing to the listeners and the programming is good, then you're in a good place.
Yeah, back to what we were talking about, the difference in what we call audio level, which is more, I guess, talking about what a meter is showing when you're on a console or a DAW that you're working with, the difference in that and the sound level, because the makeup of the sound, or I guess not really the RMS, but what the ear responds to more often, that's actually the sound level. So that's why you can't really mix too well if you're doing any recording or setting up a processor as well. Although you have to pay attention to the meters, but you also have to pay attention to the ear and how it sounds to the ear, because the people listening in their car at home don't have a meter and they don't know what it's reading and don't really care. They just know how it sounds to them. So you got to take that into consideration. And what the meter may say looks good, it may be that it really is, the sound level may be too high or too low, depending on how it's set up. Is that a true statement?
Oh yeah. Larry, what the ear is probably the best RMS detector out there. And, anytime I've had someone say to me, be it with one of our products or any product, they'll say, on our processor, the meters are saying blah, blah, blah. You know what? I let it go in this ear, not that one, because at the end of the day, how does it sound? And the ear is an RMS detector. And to that effect, the key let's say, sections in our products, and I'm not trying to make this a plug for our products, but the things that are setting, quote unquote, the perceived loudness are the algorithms that are RMS driven. And that's, there's a lot to be said with regard to, if you want to use just a simple way to look for loudness, get some VU meter that's structured to operate as an RMS reading meter, and then look at different signals, and believe it or not, you'll be surprised how close it'll probably follow based on what you're hearing.
Back to the original thing that we were talking about in a particular radio station that you're listening to, the different elements coming across at different sound levels. It may be okay on the meters, but they sound different to the human ear. A dynamic type of song may be different, followed by a heavily compressed commercial. What can an engineer do to address that situation, to try to make everything sound the same, not meter-wise per se, but the loudness be the same?
Larry, my mom used to say, don't answer a question with a question, but unfortunately, Mom, I have to. Your question, is it more based for radio or for television?
Well, radio. Well, television went through this, a while back, with the commercials coming on, and after watching the soap opera, and the commercial comes on and blows you off the couch. And it got so bad, as most people know, it got so bad, they began to complain to Congress, and Congress went to the FCC and mandated they do something about it. And that was the beginning of the what was called the COM Act, to
COM Act,
do that.
right.
But we don't really have that in radio. And there seems to be, in listening to radio stations, and I'll interject this just for what it's worth. John and I both do inspections, ABIP inspections down in the Southeast. And I can't tell you how many engineers I've asked the question, do you listen to your station? And I've had comments like, well, no, I don't particularly care for the format, so I don't listen to it that much. But the engineer needs to listen to the station and listen for stuff like that, where there are differences in the elements. So my question is, I guess we're pointing toward radio right now. What can the engineer do to sort of ensure that the different elements in the program end up being the same, to use that word, loudness?
Well, first of all, I would say that if your transmission system is set up properly, especially the audio processing, that should take care of all this. That being said, I realize that there's probably a lot of broadcasters today that are operating either with a lot of computer based automation or syndicated signals coming in from the internet or satellite. You basically want to see to it that all content, if it's live or not, is set up to be operating within within what I would say would be a fair window, so that if audio levels are hitting, if it's VU meter based, you're peaking around 0 VU. Now, to the one thing you mentioned, Larry, if you've got some commercials that are coming in that have been hyper compressed, well, I don't know how much that should fall on the engineer's shoulders to, that this one commercial just sounds glaringly annoying, every time it hits the air. Probably you need to bring it up with the folks in the production department, see if they, if somehow it got recorded that way, or if they need to apply like some, dynamic expansion to open it up a little bit so that it, would appear more appealing. But I think a lot of it comes down to just, seeing to it that that everything in the chain, if you will, is operating as it should. And if you've got your processing set up correctly, I would say that, what we're talking about should be minimal at the worst.
Well, I know in the recording, in the pro audio side of the world, and we do a lot of talk about gain staging, which is extremely important when you're either doing a live performance or recording a song or something. But I think gain staging is important in radio as well, to make sure that everything as it goes through the plant stays where it's supposed to be. I was once told by somebody, you should have the gain set throughout all the different devices that your signal is going through, so that you go to any place in that line, that program line, and the level would be the same. It shouldn't be going up and down and up and down. And I've seen that at stations where they don't have it set right, and it comes out of a piece of equipment at one level and it comes out of the next one at a different level. It's just all over the place, and that just sort of complicates the matter. So I guess the proper thing is go through and gain stage all the everything that your program is going through.
Well, Larry, that all comes back to what we were talking about just a few minutes ago. If everything within the transmission path is set up properly, then what you're describing shouldn't occur. I mean, if by example, if we're talking about a facility that's a digital facility, well, you want to see to it that, and I see somebody just posted a comment here, signal unity. I mean, they're correct. You want it to be such that if something on the console is going to hit 0 dB FS, it's going to hit 0 dB FS at every stop along that path until it gets to the transmitter. I mean, that, if you've got it set that way, then what's happening at the console is going to be happening exactly the same throughout the rest of the transmission path. Just as back in the days of analog, we would set all the gains such that whatever the clip point was in the audio console was the clip point in the distribution amplifier, was the clip point at the input of the processing chain, so that whatever the console was doing is what the rest of the system was going to do. And, again, that comes back to at some point, somebody taking the time and going through the facility and getting things set up in that manner. And it's not like this has to be done every day. I mean, if you get it done right the first time, you set it and forget it. I mean, the only time you're going to have to come back to it is if, unfortunately, if something decides to get sick and it needs attention.
Yeah, in our radio class, which we actually have one of our classes coming up the week of the March the 7th, one of the things we discussed that I encourage engineers and those in our classes to do is create a line drawing of your plant. And I know TV guys do this very well. Radio doesn't do a very good job of doing that. And I tell them that it's not that it's not that difficult. It's just a simple block diagram. And I started the transmitter and worked back.
Yep.
And from the transmitter all the way to the STL to the everything back. And then what I suggest to do is pull the manual for each piece of equipment, excuse me, each piece of equipment, and see what the maximum clip level is in that piece of equipment. If it's plus 24, then everything is plus on everything, then your clip level in the plant is plus 24. But if you have an older piece of equipment that you just love because it's been doing a great job throughout the years and you've got it in there, and you read in the manual that the clip level on this device is plus 20, then that becomes your standard for your whole plant. It should be plus 20.
But you described it perfectly there, Larry.
And if you do that, like you say, you don't have to do that. You just do it once and get everything set and go from there. Let's talk a little bit, Frank, and I don't know how much you get involved in the recording process in a production room at a radio station, but I see so many people now say, well, when I get through, I'll normalize it. And I have real concerns about normalizing, whether that really is a positive or negative, or really helps, or does it help or hurt? What's your thought on when they go in and say, well, I'll just record it and don't worry about the level because I'm going to normalize it?
Well, I mean, it's been quite a while since I've been around and had to interface with folks in a production facility, on account of the fact that so much is now done, on a computer based, like dealing with an audio workstation. If they've set up their software and the normalization, because most of those options or plugins allow you to set where you want the normalization to be. If it's set to operate at at like a recommended operating level, that's going to be on par with everything else. I don't have a problem with it, because the difference with normalization is a lot of times it's something that's being applied to a file that's going to say, okay, I'm going to average out where this audio signal is, and I'm going to then come back and set the overall gain for the file to be at level X, and then hence that's that normalized signal. And again, we come back to what we've hit on a few times here this morning, is that if everything is properly implemented, installed, or set up, there shouldn't be any issues.
Well, one of the things that I see when people do normalize, they actually use sometimes peak normalization, where they try to get all the peaks to hit at a certain level. Well, if the average is down low, then they've got everything set to the peak level, then, and the other audio is much lower than the peaks, then the loud, we go back, here we go again with loudness. You go back to that, or the RMS is too low. So that was where my comment came from, and see what you thought.
And again, it comes to, in the example you just described, it's, being able to have whoever the operator is, if it's a production person or somebody running the audio console, or the talent of understanding this. I mean, it's every now and then back in my day-to-day life in radio, if something appeared on the air that like it was off, like a bit too quiet, 9 times out of 10 I'd walk in the air studio, and sure enough, the talent had gone to get something to drink or go to the bathroom, and the VU meter on the console was might be peaking at -10. Well, sure enough, the processing was doing its best to fill it in, but it was operator error.
Yeah, that still happens a lot, I know.
Yes, it does.
Yeah. I want to touch on an item here that you touched on earlier, and to get your feelings on it. There's new philosophy out now about loudness standards, and there's something called LUFS, LUFS, loudness units full scale, and the R128 you were talking about that the agency over in Europe came up with. And there's been a lot of controversy about that. Some people like it, some people don't. It's to come up with a sort of a loudness standard. Do you have any thoughts on that going forward?
Well, first of all, some of it comes back to something you mentioned earlier. I mean, we all hear a bit differently. And I do know, because I've sat in and listened and debated, by the way, with some of the folks in the AES group dealing with loudness. Some of it to me appears to be maybe a bit too conservative. And I come back to the topic I mentioned prior, that I think loudness has been given a bad name because of how things have been applied towards it. But it's something that exists today. There's this big push with regard to streaming audio, to keep it within a certain, loudness restriction. You can set things to where meters are going to operate such that some R128 loudness monitor is going to indicate a certain value, but you can create an affected sound even within that signal that's going to sound to where it may appear louder. Look at radio. I mean, if everybody's operating such that their modulation's hitting 100% modulation, somebody's going to appear louder, quote unquote, based on how they're processing or how their equipment is set up. So, I think there's a part of me that thinks it's a Band-Aid for a problem that may or may not be there, quite honestly. And so now that all said, and being somebody that manufactures equipment for broadcasting and the professional sound industry, if we need to have our devices adhere to certain criteria, obviously we will do that. But I think as operators, you apply common sense. If you do things, in a commonsensical manner, you'll be able. Here's something that may touch on it. I recently was on a couple of discussions with folks from the AES, and there's a thing where they've got they want to have this other form of radio that's tied into. It's not just streaming, but it's HD radio and streaming, and where the listener can select different things, and they want to come up with a proper loudness operating level, and I said to the group, and I was glad that some broadcasters agreed with me, and I wasn't trying to be right, mind you, that you can set up all this criteria for loudness. Okay, look at television, perfect example. Supposed to adhere to the CALM Act, and they still have problems, right? Look at the Super Bowl. Halftime was a joke, and that was all audio based. If you really want to deal with loudness, it shouldn't be done on the broadcasting side. It should be done automatically on the consumer side, where if it's television in the set-top box or the set or the app, where there's some R128 loudness mechanism that's setting the incoming level to be operated at a certain loudness level, then the listener or the viewer can then set their volume to be whatever they want it to be, and it'll be that way consistently. You could do the same in radio. The radio could be set so that the loudness mechanism is set. And then, as you mentioned at the top, Larry, there's a thing called the volume knob. You set it to whatever level you want, and theoretically everything should stay there.
And that's something that should be in the receiver and not at the broadcast. That's
what I think. But and by the way, some of the folks that are promoting it all being on the broadcaster side, good minds. I said to them, group, if everything was set up to operate as you describe, your method works. But let's be honest about it. I'm not saying people are going to purposely adjust things, but they happen, right? How many in broadcasting today, you have an engineer, and he's got the responsibility of half a dozen or more radio stations, right? And maybe a television station thrown in or two. The amount of time that individual is going to have to go painstakingly through and make sure everything is perfect, and that's difficult. So let's take the challenge out of the hands of the real world that we have today, where mistakes can happen, and I'm not trying to put blame on anybody, but we could automatically fix all this on the consumer end for radio and television. And by the way, I'm happy to put my money where my mouth is, because I see somebody who's posted metadata, and I have a comment about that too. I've done this work on what would be the consumer side. My comment about metadata, it was designed into the digital television system, except it has a huge fatal flaw. A lot of the metadata is human set. So how many of those commercials that come blaringly loud? Why? Because they purposely said dial norm incorrectly so that it would come out blaringly loud. Yours truly, back when the digital television system first came along, I saw this, and I was at it was in San Francisco at a AES convention, and I got to know a lot of the gang from Dolby. Actually, later on, Tim Carroll came to work for our company, and he's back with Dolby now. And I told him, I said, guys, people are going to misadjust dial norm. And they're like, no, they won't. Yes, they did. So what did we do? We made a television audio processor that, yes, it does processing, but it also reads metadata. And if the metadata has been improperly authored, it reauthors it so that the audio and the metadata is done correctly. Now, if we do it for radio, then metadata should not be allowed to be a human adjustable parameter. It needs to be set, in the design of all the transmission equipment, so that the problem that I just described that happens on a day-to-day basis doesn't occur. Or we put it on the consumer side, then automatically problem goes away.
Yeah, that's a good thought, and you can see how that works out. I've got something here. If we just take a couple of minutes here, there is a group over with the EBU that put together a really nice video, and I think Frank, you've seen this video.
Mm-hmm.
And I took a little clip out where they're talking about the normalization and how the LUFS fits into it. And if I can get my video to play here, I'll let you listen to this. This is pretty interesting.
All right, just a very quick animation to illustrate that concept of peak versus loudness normalization once more, just to give you a very good grasp on that. So we still have this kind of reference peak level in broadcasting. Yeah, that's our reference. And all those tools now should represent individual programs. Yeah. And the size of the tool, so to speak, represents the dynamic range of things. So they are all aligned according to their peaks. So the sword here might be a highly dynamic action film, and this one might be a highly compressed commercial. So if we look at the loudness level of these programs, that would be the center of gravity. So as you know, TC Electronic called the loudness level center of gravity. Yeah, so that is a very good comparison. If we draw that in, that would be these green circles. You see the problem that we have. So if we connect the dots, you see all those loudness jumps that we have today. So huge jumps between dynamic material and highly compressed material. So what did we do in broadcasting, or what do? We compress. Yeah. So we compressed, not the hell out of it, but this is exaggerated, but we compressed because obviously the situation before was not satisfactory, because these huge jumps were just too much. So now we have the same peak level, but in this case we also have the same loudness level. So yeah, great, problem solved. But we sacrifice, of course, a lot, because we sacrifice all the nice dynamic range, for instance, of these feature film. So now with the Sylvester Stallone movie, the dialogue is as loud as the gun battle, which maybe would be okay for a Sylvester Stallone movie, but maybe not for other movies, So we sacrifice all the nice dynamics on the altar of this kind of compression loudness normalization. So compression is one solution, but it's not the good solution. Of course, the real solution is loudness normalization. So you can probably imagine what is happening in our case here with these dynamic programs. We get rid of this reference at the top. We get rid of a peak reference. We introduce a new loudness reference level. And now we align every program with its average loudness level to this new loudness reference. That's the idea. That's the concept of loudness normalization. And that's our audio nirvana, where we want to go to. So that's what we want to achieve. Yeah, that's the goal.
So I'd like to have your comments on that, Frank, and how you see that working.
Well, you know, I use the term nirvana, and all due respect to our European colleagues, I come back to what I said earlier. A lot of it comes down to, you know, how things are set up and operated. I have. It's been my observation, having traveled to and visited and worked with many, and I mean many, European broadcasters, where there's more of a penchant there to put the meter reading before what the ear hears. Where I'm of the opposite. There have been times, group, I've heard something come out of the speakers that I've thought, wow, that sounds pretty good. But then I'll look over at a meter and like, especially in designing stuff for signal processing, I always have an oscilloscope running, analog oscilloscope, by the way. And I'll look at it, I'll say, something's wrong, because what I'm seeing on the waveforms should be sounding a lot more nasty than what I'm hearing. And that all comes back to how algorithms operate, how things are applied. So to what the video that you shared, which, was done a few years ago, in theory, it makes a lot of sense. I think, I think TC Electronic has one of these, loudness measuring graphics for television that, if you keep everything within this line, on this polar plot, everything should be okay. But yeah, you can do that, but what you're hearing what the ear's hearing may not be in agreement with what's being seen on the meters or on the plot. So, I think for our world, meaning broadcasting, it comes down to how things are. Yes, you want things to operate within, a good operating range within the facility. But at the end of the day, loudness is all going to be governed by how things are set up to be processed to go to the transmitter. I mean, it's always going to be that way. And then if you're going to get into some dialogue about the perceived loudness of the radio station, well, that's also a discussion that's not just technical, but it's programming and management in nature as well.
Yeah, I think the idea behind what he was talking about from a technical standpoint makes pretty good sense technically.
Yeah,
where you
I agree.
You do all you calculate what the loudness is, and you set a level, and you're not supposed to go over that. I think what the EBU came up with was like an LU reading of like -23, and if every broadcast station set theirs to -23 as what their loudness level is, and some of the stations obviously would have to get louder because they're lower than that. Stations that are loud now would have to come down, and they would be lower than they are now. So I think that's what he was trying to cover. They actually do make, and I know you some an LUFS meter. This is a plug-in meter you can get. It's actually free, which actually shows the different, and they read it in short term and integrated loudness, and so you can actually see exactly how all that works. But again, like you say, it's all back. It has to do more with the ear than anything else.
Fully agreed.
And finally, we were about to run out of time here, but I did want to talk about a little bit about, and you touched on it briefly, about streaming. The more I read in the trades now about radio and it appears that a lot of the revenue income now, a good amount of it is actually coming from non-traditional ways of getting the signal out there as over the air. Now they're streaming and doing other things. The processing is entirely different from what you're feeding to a stream than what you're feeding to the over the air. You might talk about that a little bit and things to watch out for if you're streaming your station.
Well, sure. Streaming is basically another transmission platform, just as is AM, just as FM, and every one of them have unique challenges, if you will. And in the streaming world, we're dealing with audio codecs, and the things that are going to govern the resulting perceived sound is going to be the bit rate. And, in this day and age, we're all trying to get the most bang for our buck. So the least amount of bits that somebody would need to use, well, as you scale the bit rate down, the codec has to operate much more aggressively. The processing needs to be employed that's designed to work with a codec. And this, it's not acceptable to just take if you're going to stream your over-the-air content, it's not acceptable to just take, like a demodulated signal and plug it into the encoder. Reason being is if it's AM or FM, there's been aggressive processing applied, such as clipping, even though it's been distortion managed. Audio codecs don't like that. That's a given that no matter how much you want to debate it or argue it, you put clipped audio or audio that has a lot of intermod distortion that can be generated by fast time constants and limiters. Codecs don't like that. They'll generate their own nasty anomalies. So what needs to be done is you need to employ a signal processor that's designed for streaming. And some encoders have a processor built in. Some over-the-air processors have a section that will do the processing that can then go to the encoder. But the important part is to ensure that you're using a device that's designed for an audio stream. And by the way, when you think of audio streaming, HD radio falls into that, because what's HD radio? It's bit rate. It's bit rate reduced audio. It's just being done, electromagnetically over the air. So it's the same thing.
Yeah, I know the streams that radio stations use probably are a little different from the commercially streams that people use, like YouTube and Spotify. But I read the other day that those type streaming services actually are using LUFS now, going back to LUFS.
Yep.
And if you can actually, there's a place where you can go on the website and some of the DAWs that are out now. I know that the Studio One, which is a DAW produced by Personas, they actually have a section in there where you can go and click on and tell the DAW what streaming service you're going to send it, and it will automatically set it to what they want. And if you send it too loud, they're going to turn you down. So, that may be the same on streaming services that radio stations are using.
Well, there's that, and I think there's a lot of broadcasters that are basically contracting out their streaming, where they're basically handing off their content and they're leaving it to like a third party to manage it. And I think there's a couple of the larger broadcasters that are doing it all in house, but that whole world is operating a bit different than what most of us have known in day-to-day over-the-air radio.
Well, Frank, I think this has been a very enlightening program, and it is something that I think we're going to deal with from quite a long time, because I don't think there's any way that we can actually solve it in just in one day. Agreed. Trying to get the loudness and all set up like it should be. So Frank, we want to thank you for being with us. And
Thank you for having me.
John, you have any comments? John
Well,
went to sleep, I think.
Yeah, no, I'm right here. I just can't push enough buttons at the right time. But I certainly appreciate Frank being with us as well too. And it's always enjoyable, and I always learn something. So that's a good positive. I will mention just a couple of notes. You should keep your eye on FCC enforcement. There is a new director of the FCC Enforcement Bureau, and we don't know exactly how that's going to affect the broadcast stations at this particular point, but I do know that the FCC has been cracking down on overpowered translators. And when I mention, I do know that's out of the Atlanta office, because there have been some unplanned visits to translator sites that have been operating over power. So if you know of anyone and you want to keep them clean, I would certainly recommend that you talk to them about them operating over power as such. And then there's a lot more coming down the pipe over the coming months that we'll keep you posted on as well. And of course, that brings us back to both Larry and myself, ABIP inspectors, and Larry's cranking up ABIP inspectors in Alabama. And of course, we're doing the same thing in Georgia and South Carolina. So the ABIP inspection program is quite a good program. It keeps kind of helps keep your facility clean and out of trouble with the FCC, and it's highly recommended, and very valuable service put on by the broadcaster associations. And that's all I have, Larry.
Okay, thanks, John. And we want to thank everybody for being with us today. Our next meeting will be on March the 15th. Kirk Harnack, who was supposed to have been with us with our Alabama Broadcasters Convention, which we had to postpone because of the pandemic, is going to join us and talk about IP maintenance, things to look for in your studio, since everything now is pretty much riding along the IP stream. So make a note on your calendar for March 15th for the March edition of the Broadcast Engineering webinar. So thank everybody for attending, and we'll see you next month.